Welcome! Today, we're going to break down one of the most powerful ideas in all of programming, object-oriented programming. And we'll see how its most famous language, Java, uses this idea to build entire digital worlds, all from a set of simple blueprints. So here's what we're going to cover. We'll start with why we even need this stuff, going from chaos to order. Then we'll dig into the core ideas, the blueprint, which we call a class, and the actual building, which is an object. After that, we'll see why Java is the perfect tool for the job, and we'll wrap up by walking through your very first program. All right, let's dive in. First up, Section 1, from chaos to order. To really get why object-oriented programming, or OOP, is such a big deal, you gotta look at how things used to be done. It was, well, a bit of a mess. Okay, check this out. On the left, you've got the old procedural style. All your data is in one big pile, and you have a bunch of separate functions that just reach in and mess with it. When your program gets big, this turns into total chaos. It's so easy to break something. But look at the right. The object-oriented approach is way smarter. It bundles the data and the methods that work on that data into a neat little package, an object. It's all about keeping things organized and self-contained. All right, on to Section 2, the blueprint, classes. So if this whole OOP thing is about building with these objects, where do they come from? Well, it all starts with something that works just like a blueprint you'd use for a house. In programming, that blueprint is called a class. A class is just a plan. It doesn't do anything by itself. It's a template that says, hey, any object of this type is going to have these characteristics, and it's going to be able to do these things. For instance, here's a blueprint for a vehicle. The class would define its attributes, that's its state, the stuff about it, like its license plate or its speed. And it would define its methods, that's its behavior, the things it can do, like start the engine or accelerate. The really cool part here is how this separates the idea of a vehicle for any actual car on the street. Which brings us perfectly to Section 3, the building. Objects. So if the class is the blueprint, then an object is the real thing you actually build from it. This quote from the source material just nails it. Objects are the real live instances of a class. The key words there are dynamic and instance. Think about it. You have one blueprint for a car, right? But from that one plan, you can build thousands of individual cars. Each one is a unique object, a real instance of that blueprint. So what does this look like in code? It's pretty much a two-step process. We call it instantiation. First, you have this line. Point P1. All you're doing here is telling the computer, hey, make a space for me. I'm going to have an object based on the point blueprint, and I'm going to call it P1. You're just making a reservation. And then comes the moment of creation. You use the new keyword. This is the part that actually builds the object in the computer's memory. This is when the blueprint becomes a real thing. And we give our specific P1 object its own unique data. In this case, an x-coordinate of 10 and a y of 20. And this table right here shows you the real power of OOP. From that one single point class, that one blueprint, we can create as many unique point objects as we want. Look, P1, P2, and P3 are all points, but they're completely independent. Each one has its own state, its own coordinates. It's just incredibly efficient. Okay, that brings us to Section 4, Java, the master tool. So we get the concepts, right? Classes are blueprints, objects are the build-ins. So where does a language like Java fit into all this? Well, it's basically the master tool for bringing these ideas to life. Java was designed from the ground up to be simple, reliable, and absolutely, fundamentally object-oriented. But its real killer feature, the thing that made it take over the world, is that last point. It's platform independent. And what that means is you only have to write your code one time. That's it. This became Java's famous slogan, write once, run anywhere. It was a total game changer, and it's all possible because of this brilliant process you see here. You write your code in a .java file. The compiler turns it into this intermediate thing called bytecode. Now, this bytecode isn't for a Mac or a PC. Instead, it's for a Java virtual machine, or JVM. The JVM acts like a universal translator, allowing that exact same bytecode to run on any computer that has a JVM. It's genius. Okay, that's enough theory. Let's see what this stuff actually looks like. Time for Section 5, your first program. Here it is in all its glory. Now, I know it might look a bit intimidating with all the keywords and curly braces, but trust me, every single part has a job to do. Let's break it down, line by line. First up, public class hello. See? Just like we talked about, everything in Java lives inside a class. This line defines our main blueprint for this little program. And a key rule, the file has to be named hello.java to match the class name exactly. Now, this next line, this is a special one. This is the main method. You can think of it like the front door to your program. When you tell Java to run your code, the JVM looks for this exact line to know where to start. It's the official entry point. And finally, we get to the instruction that actually does something, system.out.println hello. This is the command that prints a line of text out to your screen. And what's cool is, even in this tiny program, we're using one of Java's built-in objects, system.out, to do the work. Oh, and every instruction in Java has to end with that little semicolon. So there you have it. We've gone from the messy, chaotic old ways of programming to this elegant, organized world of objects, all defined by class blueprints and brought to life by Java. You now have the fundamental concepts for how modern software is built. The only question left is, what will you build with them?